One of the great benefits of object-oriented programming is that it lets us take advantage of an idea called encapsulation. This really means nothing more than writing your code in such a way that everything inside your object appears to be wrapped up inside a capsule or a container of some kind. The beauty of this is that you can then make huge changes to what goes on inside the object, and the rest of your program neither knows nor cares. And this is great. It means the rest of your program just uses the object, and later if you decide you want that object to behave in a different way or to look a different way, you only change it inside the object itself. The rest of your program doesn't know, it doesn't care, it doesn't have to change a bit. The object is taking care of itself. Let me show you what encapsulation looks like with our running example of a car. So here's the car that we've made so far. It's a class named car. Inside we have 5 instance variables, we have a constructor, and we have 5 methods. So let's smush this together to save some space. Suppose we want to create a new car, say a red car. Well, we know what to do. We create a new variable of type car. We give it a name, I'll call it red car, and then we assign it the value that comes back from calling new, followed by car, the constructor with all of its arguments. Now suppose we want to later set the speed of the car to 3. Well, we've seen how to do that. We take the object red car, follow it by a period, and then the name of the instance variable, here it's speed. So if I say redcar.speed equals 3, then I'm reaching into redcar and I'm sticking the number 3 into the variable speed for that car. And this is not the way to do it if you are thinking about encapsulation. Instead, we're going to open up the class car and we're going to write some new routines. We're going to write a routine called getSpeed. It returns a float, and all it does is return the value of speed. And then I'll write another routine called setSpeed, and it takes a new speed as an argument and it assigns that to speed. The words get and set here are very common. People sometimes even call these little routines a getter and a setter. Using these, I can now set the value of speed by calling the method setSpeed. So now, rather than reaching into redcar and setting the value of speed directly, I'm sending a message to redcar, and I'm telling it, I want you to set the value of speed to 3. Now you might be wondering, what's the advantage here? We've just written 2 new routines, we've just made things a lot more complicated. There's no value here. Well, there is value, because suppose that later we decide when we change the speed of the car, we want something to happen. Let's look at the code. Maybe when we change the speed, we have a little puff of smoke come out of the back of the car, like it was kicking up some dirt when it changes speed. And then inside the car, the speedometer has to change, and so we have to call update speedometer. Well, these are changes that are happening inside of car. If we went with the first approach and said redcar.speed equals 3, then make puff of smoke and update speedometer would never get called. But if we always call setSpeed, then we can change anything that happens inside of car. And every time we change the speed, all sorts of other stuff can happen. Well, of course, we can write a getter and a setter for everything. And so we can have a get speed and a set speed, a get color and a set color, get position and set position. In other words, we're going to look at those 5 instance variables at the top and hide them from the rest of the program. Nobody else gets to see them. The only way that other objects talk to car is by calling the constructor, calling one of the methods we already had, like go forward and go backward, or calling one of our new methods, the getters and the setters. In fact, as far as the rest of the program is concerned, that variable might not even be called speed. It could have a completely different name. In fact, it could be implemented in some crazy way, and the rest of the program doesn't care. That's the beauty of encapsulation. So to recap, here's our class car, and there are a few things that we expose to the world. The world gets to see the constructor, and of course the constructor takes 5 arguments. So far, those have corresponded one-to-one with instance variables, but now, well, maybe they do and maybe they don't. All we know is that these 5 pieces of information go into a car to get it set up. Now we can call all the methods that we've already had, go forward, go backward, and so forth, including render. Then we have the getters and the setters. So if we want to set the speed, we call set speed with a new value. And if we want to get the speed out, we call get speed, and it returns a float. In our case, that's just the value of the internal variable speed, but again, it could be some other thing, and it could be saved in some other way. Same thing for color. To set the color, we call a setter, and to get the color back, we call a getter. And we can write a setter and a getter for every instance variable that we want other parts of the program to be able to set and get. In huge programs that are written by dozens or hundreds of people over the course of months or years, often they will adopt this strategy and they'll stick to it very strictly. Nobody ever reaches into an object and directly reads or writes the value of a variable. Everything goes through these getter and setter routines. In smaller projects like the ones we do in processing, we often are not this extreme. We're not this strict. You will often find yourself reaching directly into an object and changing its value, and you'll do that all the time. And that's just fine. That's part of the pleasure of being in total control of a reasonably sized project. The rules are flexible, and you can just do what seems best. But when you're done with a project, you might think, I really like this car I've made. I put a lot of work into it. It does a lot of things. And someday I might want to use the car again in some other project. At that point, you might want to think about wrapping things up with getters and setters so that, say, a year from now, you can just pull that source file out, drop it right into a new project, and then start using car immediately by calling the constructor and calling all of the methods. And you never need to look inside that file to figure out what's going on inside. And you never need to talk to the variables. You just use the methods. Even if you aren't super strict, encapsulation is wonderful because it lets you change just what's going on in the object definition without changing the rest of your code. So let's look at this in practice. Here's my little program that draws a whole bunch of random cars. They're different colors, they're traveling in different directions at different speeds. We have sedans, vans, trucks, and race cars. I can select one of the cars, it gets a big dot on it, and I can send it instructions like turn right twice, I can make it go faster, and I can slow it way down. So these are the cars, and this is a nice little program. But suppose I decided I wanted my cars to look more realistic. Right now I have 4 kinds of cars. We've got the van, the sedan, the race car, and the pickup truck. I'd like to replace these little cartoons with photographs. So I find a photograph of a van, I find a photograph of a little car, a photograph of a race car, and a photograph of a pickup truck. I'd like to use these photos instead of these cartoons. If my main program was responsible for drawing these objects, then I would have to start making all kinds of changes to my main program. I'd have to read in these photographs, I'd have to store them in variables, I'd have to have little switch statements for figuring out which picture to draw. Probably each of these pictures is a slightly different size, and so I would have to scale things. And now I have a lot of work to do in my program to make this switch. But of course, things are much easier because of encapsulation. All I have to do is make this switch in one place, in the car object itself. Then the rest of my program is completely unaffected. It doesn't know, it doesn't care how these things get drawn. It just sends messages to the cars. Go forward, turn right, turn left, and render. And when it calls render, it just gives it up to the car. It says, car, you do whatever you need to do when I tell you to render. So in the car object, I will change the code in that one place to change from drawing little cartoons to drawing little photographs. And here's the result. And I can still send these things messages. Let's find that van and send it the command to turn right. Tell you what, I'll send it down and speed it up. And the race cars should be going fast too. So let's speed up the race cars. Vroom. The only thing I've changed here is how the render method is implemented inside of car. The rest of my program that builds the list of cars and figures out where the mouse is clicked and all that stuff, it doesn't change a bit. It neither knows nor cares what car is doing inside of render. The beauty of this is that we can then change the object in any way we want. We can change how it behaves, how it looks, how it moves, everything. And the rest of our program neither knows nor cares. So objects are just a wonderful tool for organizing a large program. Each object is responsible for itself, and if later you decide that object is not behaving just the way you want, well, you just change that object, and nothing else has to be changed.